this problem we're going to be looking at the net present value and the internal rate of return of a given set of cash flows. The cash flows are over here on the right hand side of our board, and you can see that they occur at time 0, 1, 2, 3 and 4, where we're measuring time in years, and initially we have some payments out, and then finally we have a positive cash flow coming in. We were asked to calculate the net present value of that series of cash flows at two different interest rates, and then to estimate the internal rate of return. Now on the board I've already put up an expression for the net present value of those cash flows, and you can see that it's minus £150,000. That's the first entry, and that's because our first cash flow takes place at time 0, so there's no discounting required. The next cash flow is again a payment or a negative cash flow of £50,000, but this time because it occurs after 1 year, we need to multiply by our discount factor V, and remember that V is equal to 1 divided by 1 plus I. After 2 years and after 3 years, we again have payments of £50,000 or negative cash flows of £50,000. So we have to multiply those by the appropriate discount factor, and for the payment at the end of 2 years, that's V squared. For the payment at the end of 3 years, it's V cubed. Finally, after 4 years, we have a positive cash flow, or we get a payment of £500,000, which we have to multiply by V to the power 4 in order to have the present value. So in part A, we were interested in the NPV at 15% per annum. And if you calculate V and then plug the numbers in, we get 21,715. In part B, we're doing a very similar thing. We have the net present value, but we're asked to use an interest rate of 20% per annum. This time, plugging in the numbers gives us minus 14,198. Let's have a look at the internal rate of return now. We're asked to use linear interpolation to estimate the internal rate of return. Now remember that the internal rate of return is the interest rate for which the net present value function is equal to 0. From A and B, let's let I1, Y1 be equal to this pair. That's our 15% interest rate, and the net present value at 15% per annum. I2, Y2 is going to be equal to 20% interest rate, and the net present value at that 20% interest rate per annum, which was minus £14,198. If we are interested in another pair, an interest rate of I star and the corresponding net present value Y star, by setting Y star to 0, we can come out with an estimate of I star, which will be close to the internal rate of return. So in particular, our internal rate of return, or in this case we've called it I star, is going to be equal to 0.15 plus 0 minus Y1, which was 21,715, multiplied by I2 minus I1, which is 5%, divided by Y2 minus Y1, which is minus 35,913. The important thing to note is that if we want I star to be an estimate of the internal rate of return, then Y star, the net present value using this interest rate, has to be set to 0. So in this case, we have I star is 17.9%, and that's an estimate.